Okay, for this problem 14.21, it says a 2.50 kilogram mass on a spring has displacement as a function of time given by the equation x times t equals 7.40 centimeters cosine 4.16 radians over seconds times t minus 2.42. And the part A is asking find the time for one complete vibration. So first, I got these oscillation formulas, which is F equals 1 over T and angular frequency times 2 pi F. So I put this formula in here. So I got W equals 2 pi over T, and then I solve for time, 2 pi over W. So we just have to plug the information, and we got that the angular frequency is 4.16. So T equals 2 pi over 4.16, and that is 1.51 seconds. Okay, for part B, it's asking to find the force constant of the spring. Okay, for part B, we will use this oscillation formula, and we have to solve for K to find the constant of the spring, the force constant of the spring. So that's K equals M W squared. So now we just have to plug our numbers in order to get that. So we have that the mass that I didn't put it here, but the problem says the mass is 2.5 kilograms. So 2.5 kilograms times the W, which is 4.16 squared, and that's 43.3 newtons times meters, and that's part B. For part C, it's asking to find the maximum speed of the mass, so we have to use this oscillation formula, which is B max equals W times A. So we know that W is 4, the W is 4.16 times the amplitude, which is 7.40, and that's 30.8 centimeters per second. And if it's asking in meters, you just have to divide it by 100, so 0.38 meters per second. For part D, it's asking to find the maximum magnitude of force on the mass. So we're gonna use the force max equals K times A, and that's, so our K is the number we just got, which is 43.3 times the amplitude that we already know, 0.074 meters, and that's 3.20 newtons. Then for part E is find the position of the mass at t equals 1. So now we're gonna use the formula, the big formula that they gave us, and we're just gonna plug the 1 into it. So it's x1 equals the 0.0740 meters cosine 4.16 times the 1 minus 2.42, and that's going to give us a position when t equals 1. So when you plug that in the calculator, it will give you negative 1.25 times 10 to the negative 2 meters. For part F, I'm sorry, I think I said part E on the other one, but it's part F. E, and this is part F. For part F, is asking find the speed of the mass at t equals 1. So we have to do the derivative of the other one. So the derivative of that is going to give you negative W amplitude times sine times the WT, and now we can plug the numbers that we already know. So negative 4.16 times 0.074 times the sine of 4.16 times 1 plus negative 2.42, and that's gonna give us 0.303 meters per second. So the next part is part G, and for part G we're gonna use this acceleration formula, which is ax, well, it's asking find the magnitude of acceleration of the mass at t equals 1. So we're just gonna use this acceleration formula, which is ax minus w squared x, and that's gonna be we just have to plug the numbers we already have. So it's gonna be negative 4.16 squared times negative 1.25 times 10 to the negative 2. So that's gonna be 0.216 meters per second squared. That's gonna be the acceleration. And the last part is part H. Part H, we're gonna use this force formula, which is Fx equals minus K X, and then the same thing as the other one, we're just gonna plug the formulas for the magnitude of the force. So we just have to plug 43.3 times the negative 1.25 times 10 to the negative 2, and that's going to give us 1.540 newtons, and that's it.